In this video for Computer Science 9618, we're going to take a look at a full paper 2 walkthrough. This is the most recent exam that was given just a few months ago that we have access to from the spring session of 2025. This is the variant 1 paper 2. A lot of good stuff on here, which is why I chose to walk through it. So let's go ahead and get started. Let's take a look at the first question worth 4 points of the 75. A program is being developed to help the manager of a shop control the stock. An identifier table has been used during the design stage. Complete the identifier table. It may be possible on the paper 2 exam that you actually have to fill out the example value and explanation of an identifier table, which means they'll give you a variable name and the data type. You're going to write in an example value and explanation. That is also pretty easy to do. So when you're feeling stressed, don't feel stressed. You got this. You're able to do it. All right, so we look at the first example value, fruit. I know right away this is in double quotes. That tells me what the data type is immediately. I have to read the explanation so I can come up with a good variable name. A category of stock that is sold in the shop. The variable name I chose is category. Do you have to choose category? No, you don't. As long as it's an appropriate variable name, you're good to go. Now, you may be saying, could I use cat fruit to abbreviate category as cat and then just use fruit, all one word? I would stay away from abbreviations. It only takes a few more seconds to write the full name. Also, you want to let your examiner know that you know how to declare variables. Because it's in double quotes, I know it's going to be a string. It's not a string just because it's a word. It's a string because of the double quotes. Fruit is just found inside of it. The next one is 2025. That is February 20th of 2025. I talked about this on the predictions for the exams coming up in October and November, and I mentioned the date format. This is the example of what I was talking about. It's day, month, followed by the year. Now, if your country that you reside in where you're taking the exam, if you already follow that date format, it's not a big deal. But here in the United States, we don't follow that format. So we want to make sure that we're looking out for that. So anyway, when an item was sold, I came up with sell date. That's what I chose. And that's going to be the date data type because we're following that exact format. What about 12.67? It's not in quotes. So I know it's going to be a value, but it's not going to be an integer. Integer are whole numbers. So I came up with cost because it's the cost of an item. What is the data type if it's not an integer? Well, a lot of students like to write decimal, but what you want to write here is real because it is a real number, and that is the pseudocode data type. Then we have true. Notice true is a word, but it's in all caps and it is not inside double quotes. Because it's not inside double quotes, I know that it's not going to be a string. It says to indicate if an item is in stock. The variable name I came up with was in stock. It either is or it isn't. It's either true that it is in stock or false that it is not in stock. What type of data type is that? That's going to be a Boolean. Let's take a look at 1B. So here we can pick up an additional 5 points for a total of 9. It says a module sells as part of the stock control program. The table contains pseudocode extracts from the module cells. Each extract may include all or part of an assignment. What does this mean? This means we're assigning a value to a variable. We're looking for an arrow or we're looking for the keyword input. Because in pseudocode, when we do input value, and the user types something in, we're assigning something to that variable. So if I have input value, whatever the user types in, I'm assigning to the variable value. Then we have selection. There are 2 types of selection statements. These are going to be your if-then statements, and it's also going to be your case statement. So we want to be on the lookout for those. And then your iteration is a fancy way of saying loops. We're looking for those loop keywords. So let's go ahead and take a look at the first row. Result, arrow. I know right away that is going to be an assignment statement, but let me check out the rest of it. Result, arrow, calculate total. Well, I don't see anything else. That's going to be assignment. I just picked up a point. Now, while is closed. Well, while, that is a key word for iteration. Take a look at the next one. Repeat input value until cells index 4 is greater than the value. Well, I have some keywords. Repeat. I know right away that's iteration. But then on the next one, I have input value. When I type in a value, it's going to be stored inside value. I'm assigning something. That's going to be assignment as well. Now you may be saying, well, how do you know you're allowed to write two check marks inside this box? Complete the table by placing one or more ticks in each row. Read those directions carefully. If they only wanted you to put one tick, it will explicitly say one tick only. If cells index current is less than or equal to 150, here's my if statement. I know right away that's going to be selection. Then I have discount arrow true. That means it's an assignment and selection. And then I have case of option. Only one line there. My case statements, those are also selection. Let's take a look at part 1C. Decomposition has been used to design the program to help the shop manager control the stock. Describe decomposition. So they want you to be able to put into words what it means. Well, we're breaking the program down into smaller parts or subtasks, breaking it down into the smallest steps possible. What are we going to do with each of those steps? Well, it's going to be designed using a series of procedures and or functions. We're going to take each small step and give it its own procedure or its own function, and these can be managed in more detail to help with the stock control that was mentioned at the beginning of this problem. We are less than 7 minutes in, and already we have earned 12 out of 75 points on this paper 2 exam. Let's go ahead and take a look at the next question. All right, moving on to question 2. A program is being developed to calculate the pay of employees working for a company. A function, calculate bonus, calculates bonus pay based on the value of cells. Bonus pay is calculated as shown in the table. So if we sell below $2,000 in sales, they're going to give us a bonus pay of 0. Yep, sounds like a real company. If we generate between $2,000 and $4,000 of sales, making the company rich, they're going to give us a whopping $10 bonus. By the time we pay taxes, there's nothing left. I can't even order anything at McDonald's. If we make the company even richer and generate more than $4,000 of sales, they're going to give us a bonus of $100. That's less than 5%, way less than 5%. Yep, sounds like a real company. If you have a job, you know exactly what I'm talking about. A flowchart for the function calculate bonus has been designed. So when you take your paper 2 exam, they could give you a flowchart you have to analyze, which is the case here, or you may have to design a flowchart. So let's go ahead and go over the shapes and what they mean. So if you have to design a flowchart, you can be successful. Notice start and end. They are inside a oval or circular shape. If you have start and end, you're going to get a point. So if for some reason you show up to the exam, they ask you to design a flowchart and you have no idea what to do, and it's a blank page, write start and end, put them in circles, you'll at least get 1 point. But you should be able to do more because you're able to do more. You're able to do more than you think you're able to do. Let's talk about these rectangles. This is assigning values to a variable or returning from a function. Because it's a function, it's going to return a variable, in this case, bonus pay. These other 3 rectangles you see, that is set bonus pay. We're assigning 0 or 10 or 100 to bonus pay. So we use that keyword set, whatever variable we're setting to, keyword 2, and then the value. Notice it is in a rectangle. Then we have the parallelograms here. Input, value of cells, that is the user inputting something. You're also going to use this for output. Remember, when you use output, wrap what you are outputting inside quotes, please. Then we have these diamonds. These diamonds are what we call our decision statements. In other words, they are your if-then statements. If values of cells is greater than 4,000, we're going to move forward. The way the diamond shape reads is value of cells greater than 4,000. It's going to result in yes or no, just like an if-then statement. Now, if values of cells is greater than 4,000, we're going to check to see if value of cells is greater than or equal to 2,000. That is not how it works at all. Taking a look here, if we do 3,100, is 3,100 greater than 4,000? No. and we return bonus pay, I'm missing out on that huge bonus that's, not going to buy me McDonald's, because I should have my bonus pay set to 10 if it's greater than or equal to 2,000. This is actually not going to work at all. And that brings us to the question. The flowchart contains logic errors. One logic error is that bonus pay will not be set to 10, although the value of sales input is between 2,000 and 4,000. Why does this occur? Well, the error is found right here. Is values of sales greater than 4,000? If I sell 3,100 units or do $3,100 in sales, I should be getting a bonus. But 3,100 is not greater than 4,000, which means my bonus pay is going to be set to 0. I'm going to exit without getting that bonus. So that really makes it wrong. So what do we need to do? How do we fix this? Well, what we need to do is we need to check if the value of sales, or it checks to see if the value of sales is greater than 4,000. What it should do, that should happen after we check to see if it's at least 2,000. That's what should happen. How do we fix it? Well, we reorganize the selection statements for 2,000 to come first. And then if it's greater than 2,000, then we check to see if it's equal to 4,000. What we need to do is set that bonus pay to $10 though, if it is greater than 2,000, and then check to see if it's greater than 4,000. If it's not, we're going to return bonus pay, which is 10. If it is, we're going to set that bonus pay to 100. Let's take a look at the next part. There are different ways to reduce the risk of errors when developing the new program, such as the use of constants. State a value that could be replaced by a constant in the function calculate bonus. What are you looking for here? There's a lot of numbers going on. You can use any number that does not change. 2,000, 4,000, 10, 100, any of those will work. Please only choose one. And it says, explain how the use of constants helps to reduce the risk of programming errors. Well, you can ensure the correct value is being used. I type it one time into a constant, I can keep using that. If a constant's updated, I only need to change it that one time when I'm writing my code. If I want to update it later on, if the company is going to go from $10 to $11, that's never going to happen. It's probably actually going to go down, because we know how companies are. They're going to open their code, they're going to update it with that one line. Now you can use the identifier rather than writing the actual value through the program, reducing and assigning error. Here's what I mean by that. Let's say the bonus pay is 100. If I'm typing in 100, I could type in 10, hit a 0 for the third time, but maybe my key doesn't actually assign that extra 0. Now I have the wrong value. By using a constant, I'm making sure that doesn't happen. Let's take a look at this next question about libraries. There are static libraries which are built into the exe file, so they're actually part of the program. The benefit is the library runs faster. The drawback is the file size is bigger. There are also dynamic link libraries. These are your DLL files. The downside is because it's linked to the program, it's going to run slower than a static library. The benefit is the program, because it's not part of the program, like built into the exe file, the file program is smaller because it's only being called when it is actually being used. But they're not asking us about that here. They're just saying explain how library routines can reduce the risk of programming errors. One of the great things about libraries, it provides higher complex code that may be beyond the skill of the programmer. We also have already tested the program to make sure, or the code, not the program, but the library, to make sure it already works. Because it's already been tested, we know it's going to be bug-free and that it's going to be reliable. Let's go ahead and take a look at the next set of questions. All the logic errors have been corrected and the program has been coded. Now, identify and describe two other types of errors. There are 3 total. There are logic errors. Your code will compile, it will run, it will not crash, but it doesn't work as intended. It doesn't give us the expected values that we're expected to get in the output portion of our program, but it does run, and it also does compile. The other type of error that you could run into is a syntax error. Your code doesn't even compile. The syntax rules were not followed. This is when you get the red lines underneath some of your code. That's a syntax error. You didn't follow the rules. You misspelled something, a keyword you misspelled. Maybe you have an open sub with no end sub. Maybe you have a open curly brace at the start of a function but no close curly brace. If you're in Python, maybe you wrote your if statement but you forgot your colon. Maybe you didn't indent far enough. That's a syntax error. You're not following the rules of whatever programming language is being used. The last type of error you can get is when your program crashes, and this is a runtime error. Your code does compile, it does run, but at some point it's going to crash. Program attempts to do something it can't do, such as divide by 0, open a file that doesn't exist. Maybe it's going beyond the bounds of an array. We're trying to access an index that's outside the bounds of the array. In short, we say it performs an illegal operation. Those are the three types of errors. All right, question 3, we need to preview it because it's a long one, but it's worth 8 points, and this will get you to 30 out of 75. And there's nothing on this test that you cannot handle. So if you're feeling stressed, just relax. You got this. We're going to go through it all. It's just going to be another day at the office for you. Nothing that you can't handle. Remember, you've been programming. So now we get a chance to show off what we can do. So, Student has been asked to create a simple guessing game program. This program will generate a random integer between 1 and 100. It will then repeatedly prompt the user to input an integer value until they input the randomly generated value. So we're going to keep guessing until we get it correct. Now, the student has written a structured English description. Step 1, randomly generate an integer value between 1 and 100 inclusive. Prompt the user to input a value. Output it if it's too high. Output if it's too low, get it to repeat. Output an appropriate message if the value input was the same value that was randomly generated, and then we end the program. Write a pseudocode algorithm from this structured English description. They don't give us a procedure name here at all, so all we have to do is write the algorithm. You do have to declare variables. Now, we know we're randomly generating an integer. You may be saying, oh my, what is the pseudocode for that? At the end of your test, or as an insert, you're going to have a paper that's going to show you how to do some basic pseudocode that's not in the pseudocode handbook. Generating a random number, I did not see in the pseudocode handbook, but it's okay because it's right here. Let's talk about how to read this. Rand x : integer. Rand is going to be what you're going to use. You do not put a value and then declare it as an integer. You don't need to return real. What this means is I'm going to put in an integer inside these parentheses, and that will generate a real number. For example, rand 87 could return 35 with a decimal. And what's more important, it says right here, returns a real number with a decimal, in the range 0 to x, not inclusive of x. So now if I do 100, I could get the number 0, and I could also get 99 point something. So that I can't put 101 because that could be a number higher than 100. So we're going to talk about how to handle that in just a moment. And then we need this int function here. We put in a number, and then it could be a number. It could also be a variable, and it'll chop the decimal off. It doesn't round up or down. It simply chops the decimal off. So assume no input validation is needed. That's nice. Makes it a little easier to write. It's worth 8 points, and we're going to pick up all 8 points here. So I need num. That's going to be an integer. That's going to be the random number that is generated. I also need guess as an integer because I'm going to ask the user to input their guess. The first thing I need to do is get a random number between 1 and 100. So I try rand 100. I ask myself, what is the lowest number I can get? What is the highest number I can get? The lowest number I can get is 0. Well, what's 0 plus 1? That's 1. 1 needs to be my lowest number. How do I get to 100? Well, if I do rand 100, that could give me 99.99999. That is the highest number I can get. Well, I need to add 1 to get 100.9999. But 100.9999 .9999 or any decimals not allowed. So how do I fix that? That is where the int function comes in. I'm assigning the new value to num. I'm calling the int function. What am I putting there? I'm putting in num so it chops the decimal off. This will give me a number between 1 and 100. Then I know I need to keep asking the user to input a number until they guess it. So I open my loop with repeat. I output enter a number between 1 and 100 for your guess. It does tell me to give them a prompt, so I need to use an output statement. Then they're going to input their guess. All I have to do now inside the loop is evaluate to see if it's too high or too low. So if guess is greater than num, then I output it's too high. Else if guess is less than num, then I output it's too low. And if I'm going to keep looping this code until guess is equal to num. Now, once guess is equal num and we exit the loop, we output correct, you guessed it. We give them some type of appropriate message. And just like that, we now have 30 out of 75 points on our paper 2 exam. Let's go ahead and take a look at question 4. All right, in question 4a, it's worth 2 points. They give us an algorithm. I see I have a nested while loop right away. I see we have an array of chars, lower bound of 1, upper bound of 4. I starts at 2. We have ij. So we have a nested loop here. The outer loop structure used in the algorithm is not the most appropriate one to use. Yeah, when you're using an array, you really, especially if you're going to be accessing the indexes, you really want to be using a for loop. You also, if you know how many times this is going to run, you also want to use a for loop. What is that called? That's called a count controlled loop. Why would we use it? Well, because right here it says while I is less than or equal to 4, I know they have to update I somewhere, and they do right here. I becomes I plus 1. So they're incrementing it by 1. We know it's going to run 3 times because I starts at 2, 2, 3, and 4 because 4 is less than or equal to 4. So we're going to use a count controlled loop when we know the number of loops or based on the amount of indexes that are going to be used in the program. So that's why you would use a for loop. Now, real quick in pseudocode, with a for loop, the numbers, the range is inclusive. So in Java and in VB, you know that. In a for loop, it's inclusive. In Java, you're creating a condition anyway, so you know how many times it's going to run. In Python, when you write your code in Python for I in range 1, 4, you know that 4 is not inclusive. So if you're programming in Python, when you go to take your paper 2 exam, please remember that second number that you are going to use is inclusive. It's not like your coding language for Python if you're using for I in range. All right. So we answered that question, and somebody asked me, can you go through a trace table and dry run an algorithm? So we're going to go over that right now. They give you plenty of rows, and one of the questions that comes up in my class all the time, my students will ask, do I have to use all the rows? And the answer is no, because it's not always clear when you move to the next row. So what I tell my students is when one of the updated values that you already have changes, go ahead and move to the next row. You don't always move to the next row, but when should you? When a value changes or you're showing a major change in the program, meaning the outer loop and the inner loop we have here. But if you don't make it all the way to the bottom, that is okay. They want to see, did you show the values changing and did they show up as the final values? All right, so here we go. I is 2. We saw that at the beginning of our algorithm. And they filled in the indexes for us of the array chars. So while I is less than or equal to 4, well, I is 2, so we're going to run this. Key becomes chars I. Well, 2 is inside index 2, so chars 2, because it's I is the value of 2, that becomes our key. So I'm going to take that T, put it in my key. Then it says J becomes I minus 1. The value of J has now changed. 2 minus 1 is 1. Then it says, while j is greater than or equal to 0. Right now it is because j is 1 and chars j is greater than key. Well, the program needs to pull chars j. What is inside chars j? That's D. So we don't even run that inner loop. Then it says chars j plus 1, which is 1 plus 1, which is index 2, equals our key. Well, our key is already T. If you put T here on this row, that is fine. You can do that, but it's already T. It's not changing. But if you put a T here, that is okay. All right, we're going to increment I by 1. So I becomes 3. Because I has changed, I'm moving to the next row. Now, what I am going to do here, the way I'm going to format mine, is when we had the value of 2 here, I move to the next row, which is required. Here I have 3. So I'm just going to keep following the same format. If I wrote it on the same line, that would be okay. It's not about having them on the right row like it was for paper 1 when you're tracing assembly language. For this one, as long as you have the values, you're good to go. So then we have chars I. Well, I is 3. Inside index 3 is H. That becomes my key. J decrements from by 1, I minus 1. So now J has the value of 2. Well, J is greater than equal to 0. And it is. 2 is greater than equal to 0. And chars J, T is greater than key. Is T greater than H? Yes, it is. So in chars J plus 1, J is 2. So in chars 3, what am I going to put there? I'm going to put chars J, which is chars 2, which is the value of T. That is what I'm going to be using. Chars J is T. I forgot to show you that there, but I do have it here. And then we update index 3, exactly what it says here. Then we decrement J. J becomes the value of 1. Now, I'm going to run back up here to this inner loop. J is greater than equal to 0. 1 is greater than or equal to 0. I'm looking at my J value. And chars J, chars 1, D is greater than my key. D is not greater than H. My key has not changed. D is not greater than H. I exit this inner loop. Then it says chars J plus 1. J is 1. 1 plus 1 is 2. Inside index 2, I'm going to put my key, and that is H. And there's my D. Then all we're going to do is increment I. 4 is less than or equal to 4, so we're going to run it again. J becomes I minus 1. J becomes the value of 3. We load chars I, which is 4, which is the letter R. Skipped over that there, getting ahead of myself. While J is greater than equal to 0. 3 is greater than or equal to 0, and chars J. Well, J is equal to 3. What's inside index 3? Not H, but the value T. We updated that earlier. And then if that is the case, and chars J, chars 3 is greater than the key, T is greater than R. So what we're going to do inside 3 plus 1, inside index 4, we're going to put chars J, which is our T. J becomes J minus 1. So J is now 2. 2 is greater than equal to 0, and chars 2, so inside index 2 is H. It is not greater than R. We exit this loop. Chars J plus 1. So 2 plus 1 is 3. Inside index 3, we're going to go ahead and put that key, which is the value of R. And I keep, for this chars J, I keep forgetting to put that there. But that's why we're going through it. And then we are not done. Because once we exit this inner loop, this outer loop runs. We put in the R, but then I is assigned the value of I plus 1. You got to put a 5. And now you're done. You can see I didn't use all the rows, but we did go through and we updated the I, key, J, chars J, and any index that we needed to when it was being assigned a new value. That is how you run a dry run algorithm. If you look at various mark schemes, you'll see it. Sometimes they skip lines, sometimes they don't. It's really up to you, but they will give you more lines. Here, by skipping a line after I increments, I can see what's happening inside each section. And I moved to a new line, like here, J was 2. When J became a value of minus 1, which 2 minus 1 is 1. I moved to the new line. All right, question 5. Stacks and queues are both abstract data types. A stack uses a top of stack pointer to indicate the location of the last item added to the stack. Stacks are the first in, last out principle, or the last in, first out principle. The last item in is going to be the first one removed from the stack. A queue uses 2 pointers, a front pointer to indicate the location of the next item to be removed from the queue, a rear pointer to indicate the location of the next item to be added to the queue. Queue can be used to reverse the item stored on a stack. So here they show us a stack. Once it's been assigned to the queue, you can see they are in order. The items have been reversed. So when we pop from the stack, it's going to go 6, 5, 4, 3, 2, 1. Well, if we want them to be reversed and do 1, 2, 3, 4, 5, 6, we would need to add them to the queue because a queue is a first in, first out principle. Describe how the queue could be used to reverse the items that are currently stored on the stack. Your description must include how the pointers are used in both the stack and the queue. Assume the stack initially contains an unknown number of items. The queue can store all the items currently stored on the stack. The queue is initially empty. So we don't have to count how many items are in the stack and then initialize the array. We just have to assume the queue is going to hold all the items, and we're allowed to do so because it tells us that. So for 45, a total of 45 out of 75 points, what do we need to do? Well, you would first need to pop the items from the stack. They're going to like that I use the word pop because that's the appropriate term to talk about removing an item from the stack. So first, I construct a loop, and inside that loop, I'm going to pop the item from the stack. I'm going to update the top of stack pointer because it tells me to talk about updating the pointers. Then I'm going to enqueue the popped item from the stack. Enqueue means to add to the queue. I'm going to change the front pointer of the queue from a null value, such as -1, to the first index of the queue. Because if my front pointer is a null value, then that means there are no items in the stack. I need to check to see if the front pointer is null. If it is, I need to output the queue is empty. By changing the front pointer from null to the first index of the queue, it shows that the queue is indeed populated. I change the rear pointer of the queue to point to the next free space, and I keep looping until there are no items left in the stack. Then I construct a second loop. I dequeue, a fancy way of saying removing an item from the queue, and push to the stack, and I update the stack pointer. I update the front pointer of the queue to point to the next item to be dequeued. I keep looping until all the items have been removed from the queue, and that will give me the stack in a reverse order. All right, question 6a. The last one was question 5. Okay, 6a, 4 points. 49 out of 75. Now, if you've made it this far, you're pretty close. If not already, you're pretty close to an A. A program monitors the speed of vehicles as they move around a large building site. Each vehicle contains a sensor which reads an integer value that represents the speed of the vehicle. The value is expected to be in the range of 0 to 60 inclusive. The sensors cannot read values less than 0. A program module has been written to validate the values read by the sensors. A test plan is needed to fully test the module. Complete the table. The first line has been completed for you. Assume the sensors generate only integer values. So here we have a normal type of test data, 36, pretty close to the middle of 0 to 60, not in the middle, but the expected outcome data item is accepted. Let's do another normal test data. We don't run our program just once. We run it multiple times. Let's choose another value. I'm going to choose 12. Definitely closer to 0 than 60, but the data item is going to be accepted. Then we have an abnormal one. This is beyond the range of 0 to 60. It's not on the boundaries. It's right outside the boundary. Now, it will not accept read numbers less than 0. So I can't use -1 here. So any item greater than or equal to 61, the data item is not going to be accepted. That's an abnormal set of test data. Then we have boundary test data, and I have 2 boundaries. The first one's 60. Should it accept 60? Yes, it should, because it's 0 to 60 inclusive. And when you test the boundary, you want to test the upper boundary and also the lower boundary, we want to test 0 and 60. Data item is accepted. For abnormal, do you have to do 61? No, you can put in any value you want that is greater than the maximum amount, but Cambridge usually focuses on one just right above the boundary. So just like that, we're at 49 and 75 points. Let's keep rolling. Each sensor used in the system has a unique sensor ID in the range of 1 to 50. The program that is used to monitor the speed of each vehicle reads each sensor value every second, stores this value along with the sensor's unique ID into a global 2D array reading. 2D arrays can be tough. Make sure you are familiar with them. The global array reading has been declared as follows. Declare a reading array 1 to 2000, 1 to 2. That tells me there are 4,000 indices to work with. I have 2,000 rows and I have 2 columns. The array contains, there you go, 4,000 elements organized as 2,000 rows and 2 columns. So think of a giant table that you would do in your AS or A-level bio exam. You have so many rows, you also have columns. That is what a 2D array is. Column 1 contains the sensor value, column 2, the sensor ID. When 2,000 sensor readings have been taken, the array is full. The system stops taking any more sensor readings until the array has been processed. A procedure sort is needed to sort the array into ascending order of sensor value using an efficient bubble sort algorithm. On the test, they're either going to have you do a 1D array bubble sort or you're going to have to do a 2D array bubble sort. Be prepared for both. If you can do a 1D array bubble sort, you can also do a 2D array bubble sort. If you're saying to yourself, I can't do a bubble sort, then no worries. Go spend a few minutes studying how to do it, because I guarantee you, you have the skill to do so. Stop doubting yourself. Go and be great. Get that bubble sort and turn your greatness into being even greater than you already are. You can do it, but I'm going to walk through how to do it right now. So you write efficient pseudocode for the procedure sort. This means they want you to use a for loop. So what we're going to do is procedure sort. Doesn't take any parameters because we have global variables. So I need I, that's going to be for my for loop, for my bubble sort. I'm going to need temp, P, which I had an extra P. I think I just used temp. That's a typo on my part. And then max index. I can combine the same data type of variables, separate them by commas, all on one line. I would recommend doing that. If you run out of space on your test while you are writing your code, all you need to do is raise your hand, call the examiner over, and they will provide you an additional sheet. Nothing, no problems. You don't need to erase. Now, when you put in your procedure, go ahead and put in procedure on the very last line. Go all the way to the last line. Now, you may be saying, well, what if I need that extra sheet? Then cross it out and then write it again on that extra sheet. But opening your procedure and closing it, that's worth 1 of the 8 points. Declaring the variables, you're going to need those. I also need no more swaps as a Boolean. This runs very, very close to my bubble sort that I've written. Now, if you want to see how a 2D array bubble sort is being done, you can watch this. But if you want to see also an animation of it being done, you can check out the video that I have. It's called How to Do a 2D Array Bubble Sort. Okay, max index, I'm going to set to 2,000 because that's the max number of rows. No more swaps. I'm going to set equal to true because I haven't done any swaps. It's possible that when I traverse this 2D array, everything's in order. It's possible that no swaps take place. So no more swaps. I've set equal to true. I open my loop. For I equals the max index minus 1. Why am I starting at max index minus 1? Because if I'm running my bubble sort, when I get to item or index 1,999, I'm going to compare that to index 2,000. If I let this go to 2,000, when 2,000 tries to compare to the next index 2001, there is no index 2001. It's going to crash. So when you do a bubble sort, your for loop runs from the starting of the index 1 to the upper bound minus 1. So if reading I comma 1 is greater than I plus 1 comma 1, what does this mean? This means if this item is greater than the item next to it, we need to flip it around. So inside temp, what I'm going to do is I'm going to take I comma 1 and I'm going to temporarily store that in temp because I'm about to overwrite this. If I overwrite it, it's gone. So I want to back it up just in my temp variable first. So reading I1, I'm overwriting it with what was next to reading I comma 1. What's next to it? It's the next row down, I plus 1 comma 1. So then I need to go ahead and update reading I plus 1. I put it in temp. That will swap the very first column. But not only do I need to do that, I also need to swap the second column. So temp, reading I comma 2. I'm going to overwrite reading I comma 2 with reading I plus 1 comma 2. And then in reading I plus 1 comma 2, I'm going to reload what I just stored in temp. That will switch the second column. No more swaps is now equal to false because I just made a swap. And because I just started at index 1, now I got to go all the way through. Because if it's the highest value, it's going to bubble all the way to the top. But eventually, we'll get to the end. So end if, next I, max index equals max index minus 1, and then until no more swaps equals true. Make sure you set no more swaps equal true inside the loop and not outside. You can do it outside and inside. I did it in both, but you really want to do it inside the loop. You may be saying, well, if no more swaps equals false here, you're resetting it to true. Not true, not until this for loop is completely done. So your no more swaps goes inside the outer loop, but not inside the for loop. Bubble sorts can be tricky, but the more you do it, the easier it gets. And really, if you're looking at the bubble sort, it's really 4 lines of code here. You're checking to see if the first item is greater than the next item to it. If it is, we need to back up that item in temp, and we just need to override it with the next item, and then take our temp value and put it in the next item that just swapped. That's going to swap them. It's nothing that you can't handle. All right, question 7a. This will bring us 63 out of 75 points. A program is being developed to implement a customer loyalty scheme for a coffee shop. The programmer has decided that the following data items need to be stored for each customer. We have customer ID, which is a unique 6-digit string. We need to remember that because it's not a set of numbers, it is a string, and that string is a set of numbers. So not an integer, but a string. Then we have points, an integer value that is increased by 1 for every cup of coffee the customer orders. When customer visits the shop and orders coffee, the scheme operates as follows. The total number of points is increased by the number of coffees ordered. If just 1 cup of coffee is ordered and the number of points goes above 10, the cup of coffee they have just ordered is given to them free of charge. The number of points is reduced by 11. Because if they have 10 points, they order a cup of coffee, we're going to increase it by 1, which brings them to 11. Well, we just gave them that cup of coffee for free, which is why we're reducing it by 11, because when you cash in your 10 points and you get your free cup of coffee, you're set back to 0. Here, they're incrementing it, and then they're subtracting 11. So that's why they're doing that. If the order is for multiple coffees and the number of points goes above 10, then they get 1 coffee free of charge for every 11 points. The number of points is reduced by 11 for each free coffee. For example, customer currently has 9 points. He orders 16 cups of coffee. He's definitely not working at that place where they give out those big bonuses there. Total number of points now becomes 25. Customer gets 2 free coffees and now has 3 points left. So they're going to want us to write part of this. It says the programmer has defined a program module that is called every time a customer places an order, called with 2 integer parameters, the number of coffees ordered, the number of points, output a suitable message giving them the number of free coffees, return a value for the new points total. When I see this return a value, I know right away it's going to be a function and not a procedure. Let's take a look at how to write this code and satisfy this customer order condition. I know this paper 2 walkthrough is a little longer than some of the other ones, but I'm trying to think of any last minute information that could help anybody. If you're finding this video helpful, please take a moment to give it a thumbs up and subscribe to help the channel grow and those other computer science students out there. So if you could just take a moment to do that, that'd be great. Let's get back to customer order. Now we know it's going to return a value, so that's a function. They told me the name, customer order. I have a number as an integer, how many cups they're ordering, how many points they have, and I'm going to return their updated points. So I need new points and free cups as an integer. My new points are going to be how many points they currently have plus the number of cups of coffee they are ordering. For each cup, they get a point. So I'm going to assign that to new points. That's how they did it. So I'm going to follow the same procedure. We also need to initialize free cups to 0 because we don't know how many free cups they currently have. So while new points is greater than or equal to 11 and number is greater than 0, because that means I have points and I still have number cups of coffee to process. Well, my new points are going to decrement by 11 because we just added points to it. So now we got to decrement it by 11. My number of free cups increases, but then the number of cups left for free, or the number they're ordering, also decreases by 1. We're processing how many free cups they get. So I need to update new points, which I'm going to return how many free cups of coffee they get because I have to output that, and how many number of free cups of coffee are left. And I'm going to go through, I'm going to end that loop. I'm going to output how many cups they get. The following number displays coffee earned for free. And then I show that to them. And I return new points and I end the function. It is that short. It is that simple. When you're going through, just start with what you know. One step at a time. Nothing you can't handle. Sometimes the hardest part is getting started. So just go ahead and start writing. You can pick up maybe 4 out of 6 points, 5 out of 6 points, all of them. All those points add up across paper 1, 2, 3, and 4. So don't get frustrated. You've been programming. Now it's time to show what you know, and I did say that earlier. I do want to talk about the difference between arrows and the equal sign. Again, any last minute information could be helpful. You use an arrow when you're assigning a value. You use an equal sign when you're checking for equality. So here, new points, free cups, number, I'm assigning a value. I'm doing a mathematical operation, assigning it back to that variable. On the last question, when I did until no more swaps equals true, I'm not assigning true to no more swaps. I'm checking for equality in that line of code. So that's the difference between an arrow and an equal sign in case you're having trouble. All right, 7B. After we get done with this one, we'll be at 71 out of 75 points. Text file loyalty.txt will be used to store the data items for the loyalty scheme. The data items for each customer will be stored on a separate line of the text file where each data item is separated by a comma. So they're going to have customer ID, comma, points. Doesn't look like we have a space there, so that's fine. We'll be able to handle that. The contents of the text file, loyalty.txt, will always be stored in ascending order by customer ID. When the data items are read or written to the text file, loyalty.txt, they may need to be converted to the appropriate data type because their customer ID is a string. So we can't add 1 to it. We're going to convert it to a number, add 1, and then convert it back to a string. Because it is a string. Each customer has a unique customer ID. There you go. Starting at 100,001, it's in double quotes. What does that mean? That means it's a string. Oh, single quotes. If you see something in single quotes, that is the data type char, which stands for character. With this value increasing by 1 each time, a new customer joins the loyalty scheme. So we can simply increment it by 1 once we convert it to a number. When a customer joins the loyalty scheme, they are assigned to the next customer ID and value of points is set to 0. For example, if the loyalty scheme has 204 customers and a new customer joins, the loyalty scheme, the following line is added to the text file, loyalty.txt. Because there are 204 customers, the next one's going to be 100,205, 0, 0 because they just joined. They don't have any points. You can assume that the number of customers will never be more than 9,000. So we have add new customer. called with an integer parameter representing the number of new customers to be added. Okay, so we're going to have a parameter here. We're going to add a new line containing the required information to the text file loyalty.txt for each customer added to the loyalty scheme. Okay, outputs each new customer ID added to the loyalty scheme. All right, write pseudocode for the module add new customers. Assume there is at least one customer already in the loyalty scheme. So this one went 2 pages on the exam, so I'm going to use it as 2 pages here. So write pseudocode. Assume there's at least one customer. Because there's at least one customer, I need to figure out how many customers there currently are in the file. So procedure add new customers, num new as an integer. I need to know how many new customers am I adding. I'm going to declare customer ID, and I is integer. I, that's going to be for my for loop. I have line and new line as a string. I need to read the last line in the file so I know what number I'm going to be incrementing by 1. So I need to open loyalty.txt for read. There are 3 reasons to open a file. To read the file, not making any changes, you're simply gathering the information. To write, and when you write, you open it for write, you're creating a new file, or you're erasing all the contents already there and essentially starting with a brand new file, or you can open it for append, which means you're going to add information on to the end of the file. Once I open it for read, I need to loop through it. As long as I'm not at the end of the file, what file? Loyalty.txt. I'm going to read that file. Now, as I read each line, I'm going to store it in the variable line. So when I read loyalty.txt, whatever's on that line, I'm going to store it in the variable line because I am after that last number in the file. I don't know how many customers. I know there's at least one. So I need to read through that file. I'm going to end my while loop. Now, once I end my while loop, I need to close the text file. If I open it for read and then I try to open it to write or open it to append, it's going to crash. The file is already in use. So I want to make sure I close it before I need to open it again. So I open it for append. Customer ID, I'm going to take that string and I'm going to convert it to a number. Where did I get this from? I got that from the appendix or the insert. You'll have that. So if you're like, how am I going to convert a string to a number or a number to a string or any other question you have, flip back to that appendix or that insert real quick and take a look for what you're looking for. Left, this is string manipulation, also found in the insert. I want to start from the left of line and I want to get the first 6 characters. Why do I need the first 6 characters and only the first 6? I don't care how many points they have. That's worthless to me. What I care about, because I'm adding a whole new set of customers, is what the last customer ID was. That is what I need to do. Now, for I equals 1 to num new, customer ID, because I converted it to a number, customer ID plus 1. I've added 1 to it. Then I output the customer ID because it did say to do that. Then new line. I'm going to take the num to string, customer ID, and I'm going to concatenate 0 or a comma and then 0 onto it because the customer ID is separated from the 0 with a comma. And I use the ampersand when I want to concatenate strings because I'm taking a customer ID, converting it from a number to a string. I can concatenate the comma and 0 onto it, and that's going to be my new line. Now I've opened up loyalty.txt for append. I have the new line that I need to write. So write file, I'm writing to the file, loyalty.txt. What am I putting on that new line? The new line, which is the customer ID and the 0 points they have. Then next I'm going to go through and do that for all the brand new customers. I'm going to close file, loyalty.txt, because if I open it and leave it open, I could lose the contents if I don't close it. And then I end my procedure. And just like that, I picked up 8 points. And that brings us to 71 out of 75. And this last question will bring us 75 to 75. The requirements for add new customers are changed. There may be no existing customers in the loyalty scheme. Explain the changes that will need to be made to the module add new customer. Let's take a look how to do this and get that 75 out of 75. All right, the requirements for adding new customers are changed. There may be no existing customers. So, well, first we need to check if the file exists, and if not, we need to create the file. So we open the file for write to create the file. Once the file is created, we're going to add that first customer, which is going to be 100,001, and we're going to do that using append or add that customer during the write portion of creating the file. So if we create the file using write, right after that, we're going to create that new customer. If we're going to close the file, then we need to open it again using append. Now that the file is contents, we can use the add new customers module as written previously. If you're taking paper 4, maybe a question like this appears on paper 4, then we can use a try catch statement to handle those scenarios. We use try to check if the file exists. If not, we use catch to create the file and add the first customer. This will handle the first time add new customers is called, and after the first time the file exists, and we'll have at least one new customer. I do hope you guys found this information helpful. I am wishing you nothing but good luck on your test. I know you do not need it because you're ready. You know more than you think you do. When you walk into this test, I'm sure you're going to be feeling stressed, but take a deep breath and realize you've done everything you need to be ready. I know that doesn't alleviate any stress. I know it's stressful, but you should walk into this test feeling really, really happy because you know you're going to pass it and you know everything you need to just destroy paper 2. But if you did find this helpful and you haven't already, before you go on to a next video, please give it a thumbs up and subscribe to help the channel grow. And we'll see you guys in the next programming video.